Welcome to The Explainer. Today we're diving into a question that connects the huge, vast emptiness of space with the very ground right under our feet.
I know, it sounds a little like science fiction, right? But this is a very real scientific debate, and it's been going on for over 150 years. You've got one side saying they see a clear, statistically significant link, and then you have the other side, the skeptics, who argue it's just our brains doing what they do best, finding patterns where there's really nothing but cosmic noise.
So, where did this pretty wild idea even come from? Well, it's been around a lot longer than you might think. What makes the debate so fascinating today, though, is that we finally have the tools to really put it to the test.
Yeah, the idea itself is not new at all. It was first floated way back in 1853. But for more than 100 years, the evidence was, well, it was a mess. Super murky, totally contradictory. It's really only now, with all this modern satellite data, that the debate has absolutely exploded again. So, okay, let's dive into that modern evidence, and we'll start with the scientists who are convinced this connection is real.
All right, let's look at the yes camp. A group of researchers, led by a guy named Vito Marchitelli, took a deep dive into 20 years of satellite data, and they compared it with the global earthquake catalog. And what they found? Well, they claim it's a definitive, statistically undeniable link.
This number right here, it represents just how confident they are in what they found. Marchitelli and his team calculated the odds of their results just being a random fluke, and it came out to less than 1 in 100,000. Now, in science, that is an incredibly strong signal. So, what did they actually find?
And this is the cool part. It wasn't just some vague correlation. They found a really precise time lag. You get a peak in solar proton density, and then, like clockwork, 24 hours later, there's a noticeable increase in earthquakes over magnitude 5.6. And this one-day lag, it showed up consistently over 2 decades of data. Even crazier, the correlation actually got stronger for the really big earthquakes.
And hey, it's not just that one study. Another team, led by Viktor Novikov, they focused on a single, massive solar flare back in 2017. And in the 11 days right after that flare, they measured a staggering 68% jump in global earthquakes of magnitude 4 or bigger.
But check this out. This is where it gets even more specific. When that same team zoomed in on a particular seismically active zone in Greece, that one solar flare was followed by a 120% jump in local activity. Now that is a huge clue. It suggests that whatever is happening, it's not the same everywhere. It seems to get amplified in certain geological hotspots.
Okay, so the big question is how? How could this possibly happen? One of the leading ideas involves something called telluric currents. The theory goes like this. A geomagnetic storm, kicked off by a solar flare, creates these powerful electrical currents that literally flow through the Earth's crust. And if those currents happen to pass through a fault zone that's already stressed out, right on the edge, it could be the final little push it needs to trigger a quake.
And the other main theory is just as fascinating. It involves the rocks themselves inside the fault zone. See, a lot of fault lines are packed with quartz crystals. The idea here is that an electrical discharge from a solar storm could make those quartz crystals physically expand or contract. It's a process called the reverse piezoelectric effect, and this creates a tiny physical stress pulse. Again, that final nudge that could push a fault that's already on the brink right over the edge.
Okay, but that's only half the story. For every study that finds a connection, there's an equally compelling counterargument that says it's all just a statistical illusion.
For the skeptics, this has nothing to do with telluric currents or fancy piezoelectric effects. For them, it's all about our brains. Our brains are incredibly powerful pattern-finding machines, but sometimes they get it wrong. The skeptics argue that we're basically just seeing ghosts in the data. And to prove their point, a couple of researchers, Akunzadeh and DeSantis, came up with a really clever test. First, they did what the other guys did. They analyzed more than 20 years of real data, and sure enough, they found what looked like a pattern. A 33% spike in solar weirdness one day before big quakes. But then, they created 100 fake earthquake catalogs. Same number of quakes, but they just scattered the dates completely at random. The big question was simple. Would these fake, random quakes also look like they were linked to solar activity?
And the result? It was pretty stunning. When they crunched the numbers on the totally random data, they found the exact same kinds of spikes and patterns that they found in the real-world data. Their conclusion was blunt. Those promising-looking patterns in the real data, statistically, you just can't tell them apart from pure random chance.
In fact, from their perspective, this is probably the most damning piece of evidence. The real data coughed up 3 apparent anomalies. But the 100 randomly generated datasets, they produced an average of 4.8 anomalies. Think about that. The random noise actually looked more patterned than the real thing. That strongly suggests the whole correlation is just a statistical fluke.
So, where does that leave us? What if the answer isn't a simple yes or no? What if it's something more nuanced? What if both sides are actually a little bit right and maybe a little bit wrong?
A pretty recent study from 2023 suggests that maybe the scale you're looking at is what really matters. When these researchers looked at the entire globe, they found nothing. Zip, just like the skeptics said. The signal was totally lost in the noise. But when they zoomed in, focusing on 6 small, highly active seismic zones, a significant connection suddenly popped right out of the data.
And this connection wasn't random at all. It only showed up when a kind of perfect storm of conditions all lined up. You needed a shallow earthquake, a powerful solar flare, and a fast particle cloud, a CME, headed right for us. And here's the crucial bit. The sun's magnetic field, the IMF-BZ, had to be pointing south. You can think of it like a key fitting into a lock. A southward field can directly plug into Earth's magnetic field and just dump huge amounts of energy into our system. If you don't have that perfect alignment on the sun, in space, and on Earth, the effect just vanishes.
So, okay, why does any of this matter? And where exactly does it leave us in this cosmic detective story?
Well, here's pretty much where the debate stands today. You have the pro-correlation camp. They've got strong statistics on their side, especially for big quakes. Then you've got the anti-correlation camp, arguing that you can find those same patterns in completely random noise. And then there's this nuanced view, which tries to bridge the gap. It suggests the connection is real, but it's so rare and localized that it just gets lost when you look at the whole planet. And the thing is, every single one of these viewpoints is backed by some pretty compelling evidence.
You know, this whole debate is just a perfect example of the scientific method in action. It's not a straight line to the truth. It's this messy but totally fascinating process of proposing ideas, testing them against data, and then having other smart people rigorously challenge every part of your findings.
And so we're left right back at the central question, but now we understand just how complex all the evidence is. Are these correlations real signals of some profound cosmic connection, or are we just, seeing faint patterns in the noise, just trying to make sense of a chaotic universe? For now, the ground beneath our feet is keeping its secrets. As our satellites keep gathering more and more data, the answer might one day become clear. But for now, the debate rages on, and it really leaves you wondering, if the sun can be the final nudge for a fault that's on the brink, what other subtle cosmic connections might we be missing, happening right under our feet?